Okay, some new planet. The constant acceleration is going to cause things to speed up at the rate of 20 feet per second every second. So who knows what this planet is, but the acceleration is 20 feet per second every second. So if an object is dropping in the surface of this planet, its initial speed at zero, at time zero, is zero. And then it begins to speed up. So after 1 second, it's going to speed up by 20 feet per second every second. 1 second is 20, 2 is 40, 3 is 60, and so on. So suppose you are above the surface of that planet 500 feet and you drop it. So question number A, what will its instantaneous speed be at 6 seconds? So if you're looking at a table, this is seconds and this is speed. 0 is where we're going to start. 1, it's going to start from nothing and it's going to speed up till it tops out at 20. 2 is going to top out at 40. 3 is going to go from 40 to 60. 4 is going to speed up to 80. 5 is going to speed up to 100. And 6 is 120. So if you look at the clock at exactly 6.000 seconds, that thing is going to be traveling 120 feet per second. B, okay, what's the distance traveled only between the 6th and the 7th second? So this is going to be distance. So between the 6th and the 7th second, so the 7th second, that speed's going to be going 140. So you need to know the speed to calculate distance. Distance equals rate times time. Distance equals the speed times however long it's traveling at that speed. So the 6th and 7th second, the 6th second, the slowest that object is moving is 120 feet per second, and the fastest is 140. So the speed's changing, and if your speed is changing, you don't really know what to use for speed, but because it's changing at a predictable rate, we can just use halfway between 120 and 140. So we're going to use 130 as my average speed, and I only care about the distance between that 6th and 7th, so it's going to be 130 is the average speed for that 1 second interval, so times 1. So the distance is going to be, that rock is going to go 130 feet total from the start of the 6th to the start of the 7th. That will travel 130 feet. Okay, now what if we compare it to 0? What's the total distance traveled from the time you let it go till the end of that 7th second? So the total distance, I gotta go from 0 all the way to 7. So if you go from 0 all the way to 7, your average speed, halfway between nothing and 140, your average speed, the rate is 70, and the time is 7 seconds. So 70 times 7 is 490. So the total distance is going to be 490 feet. Compared to just from the 6th to the 7th, that's only going to be 130. Okay, when is it going to hit the surface of, when will this Mars rock, when will whatever planet we're on rock, is it going to hit the surface of that planet? Okay, we were at 500 feet, so 7th second, we're at 490, so it's going to be approximately 7 seconds. It's going to be really, really close to 7. Somewhere between 7 and 8. E, write a model for the distance the rock has fallen as a function of time. Okay, so distance equals rate times time. So the distance this rock is going to travel is going to be the rate. And to find the rate, so for example, we did, this was our rate. We did 70 times 7. No. My rate was 70. So you got to figure out how in the world did you calculate 70. So the rate from, here's how we got 70. We took 0 plus 140, but how did we get 140? We got 140 because it was 7 seconds times 20, and that gave us the speed. And then we found the middle of those, so we added them up and divided by 2. So this is really how we got 70. So we took the speed, which is 140, but how did you get 140? You got 140 by taking the seconds times 20. So 120 speed was 6 times 20. 100 was 5 times 20. So to get the speed, all you do is take the seconds and times it by 20 because it's increasing 20 every second. Okay, so my speed is going to be the time in seconds times 20 plus 0 divided by 2. That is my rate. That is the speed. And I'm going to times it by the seconds. So look at this guy right here. 70 times 7 gave us 490 feet. And we got the 70 from 7 seconds times 20 divided by 2. And then you're going to times that again by 7. So this 7 and this 7 are both 7th second. So these are the same things. So distance, and I'm going to replace seconds for t for time, is 20 times whatever the time is. And you got to divide that by 2. And then you have to times that by t. And you can simplify that. 20 divided by 2, so the total distance is going to be 10t times t, or it's going to be 10t squared. That will calculate the distance. F, write a model that will give the distance the rock is above the surface of the planet. So it wants the position of the rock at any time above the planet. So the position is going to be, it starts off at 500, and then you're going to minus the distance. So it's going to be 10t squared. And that will give you the position of the rock at any moment. So if you want to plug in, see where it is at 8 seconds. So 8 seconds, all I got to do is plug in 8 for the time. So 8 squared, 8 times 8 is 64. 64 times a negative 10 is a negative 640 plus 500. So at the 8th second, it will be a negative 140. So it's going to be 140 feet below the surface of that planet. Okay, so now let's look at the next question. Suppose you drop a rock from 1,000 feet above the surface of the planet. Okay, this table gives the position above the surface of the rock at any given second. The rock reaches the surface somewhere between 5 and 6. Okay, what is the acceleration? So what is the rate at which this object is accelerating each second? What quadratic equation describes this data? So this is the quadratic equation right here for this planet where the object is increasing by 20 feet per second every second if you drop it from 500 feet. So this table, we kind of got to work backwards. So this is the total distance. It starts off 1,000 feet above the surface. Now, if you start to pick it apart, that was a change of 30 feet, and that was a change of 90 feet, and that one was a change of 150 feet, and that was a change of 210, that was a change of 270, and that was a change of 330. So it is getting smaller and smaller, but it is not getting smaller and smaller at a linear rate. The further you go down, the greater the change is. So the change was only 30 units between these first two compared to the fifth and sixth. That changed 330 times. So the change is getting bigger and bigger as time goes on. Now if you examine the change, how fast is the change changing? That is acceleration. So the difference there is 60, the difference there is 60, the difference there is 60, 60, and 60. So because it is the second time, this by definition is quadratic. If the first change was always plus 30, plus 30, plus 30, plus 30, that would be linear. But because my second change is constant, that is a quadratic. And 60 is my acceleration on this planet. So this planet has double the gravity that Earth has. So let's kind of go backwards. Now you got to remember, this is going from 1,000 feet falling to the surface. So let's just look at this is seconds and this is speed. So 0, that object is going to be 0. 1, it's going to be 60. 2, it's going to be 120. 3, it's going to be 180. 4, that object's going to be going 245. It's going to be going 300. Okay, now if you want to start looking at distance, check this out. Okay, so the distance traveled from the start to 1 second, the distance is going to be the average speed times 1. So the average speed from 0 to 60 is going to be 30. Now from the first to the second, so between the first and the second, the average speed is going to be 60 and 120. So it's going to be 90. And if you find the middle of 120 and 180, that is halfway between there is going to be 150. If you find the middle between 180 and 240, halfway between there is 210. So now this distance is only, it's not the total distance, it's only the distance between these 1 second intervals. So between 0 and 1, that traveled 30 feet, and then your change is speeding up. So between the first and the second, that rock traveled 90 feet, which was tripled what it traveled from the start to 1 second. And now these numbers match up right here, 30, 90, 150, 210, 30, 90, 150, 210. So if you want the total distance, 0 is going to be 0, 1 is going to be 30, the second is going to be 30 from the first plus 90, that is going to be 210, the total distance from 0 to 2. If you want to go from 0 to 3, you got to add 30 plus 90, so you got to add your 210 plus 150 that it falls between the second and third second, and your total is going to be 360. Okay, now what quadratic equation is describing this data. So your quadratic equation, they are always going to be the same. So look at this. The distance is always going to be the speed times the time. If your acceleration is 20, you have got to cut it in half because you can't use 20. You got to take the average. So the distance equals the speed times the time. Your speed is going to be, we found the speed 60, so it's going to be 60 times the time. So if it's in the air for 500 seconds, that speed's going to be 300 feet per second. But we're going to use the average speed from 0, so we're going to divide that by 2, and then you're going to times that by time. So your equation is going to be 30t squared. That is the total distance traveled. But if you want the position above the surface of this planet, it's going to be the position equals 1000 subtract 30t squared. So on Earth, if your acceleration is 32, the distance an object travels is going to be 16t squared. Because 16 is the average between the start and wherever you end up times how many seconds it's in the air. Okay, so these two graphs, what's the difference between this one and this one? This one is it's not linear. There's no change. This is a linear graph. So there's no change at all. This is time versus speed. So time at 0 all the way to 5 hours. So you're clocking this guy for 5 hours. So 5 hours, this guy's speed does not change at all. It stays constant. So this is called a constant graph. So if there's no change, it's constant. This change is super predictable because it's a straight, the rise and run is always the same, over, up, the same amount every time. So this is the definition of a linear. So what is the total distance traveled by this guy? So distance equals the speed times the time, and his speed never changes. So it's going to be 50 miles per hour times the time, so 50 times 5. So his total distance is going to be 250 miles. Okay, now this guy, he started at a standstill, and he kept speeding up at a linear rate the whole time. At the end of the 5th hour, or the start of the 5th hour, 5 hours later, he ended up topping out at 50 miles per hour. So we're going to take that whole duration, which was 5 hours, distance equals speed times time, and you're going to use 5 for the time, but the speed, you have to use the average speed, which is going to be right in the exact middle. So the speed is going to be 50 plus 0 divided by 2. So it's going to be 25 times 5. So this guy, 25 times 5 is only 125 miles. So the first guy traveled quite a bit further. Okay, that's it. Now, what two numbers add to give you 6 but times to give you 8? You can find that answer's not too bad. It's in the natural numbers. 2 plus 4 will give you 6. 2 times 4 will give you 8. What two numbers are going to add and give you 6 but times to give you a negative 40? So the little template we're looking for, it's going to times to give you 8, add to give you 6. These numbers are 2 and 4. So if you represent this with a polynomial, it is going to be x squared plus 6x plus 8. So here's what you're looking for. What two numbers times to give you the end but add to give you the middle? And if you factor it, it's going to be x plus 2 times x plus 4. You distribute, they add to give you 6, but they times to give you 8. So what two numbers add to give you 6, but times to give you a minus 40? So minus 40 is what you're looking for on top, and add to give you 6. So you go through the factors of 40. Can you find a combination that will times and give you a negative 40? If it's going to times and give you a negative, one of them's got to be negative and one of them's got to be positive. And it should be a negative 10 and a positive 4. These are your two numbers, negative 10 and positive 4. So x minus 10 and x plus 4, times them through, they will be x squared plus 4x minus 10x minus 40. They will add to give you a minus 6, and they times to give, no, I think we got our signs wrong. They times to give you a minus 40. Okay, we need to add and get a positive 6. But right now how we have it, those two will add and give you negative 6. So they got to add and be positive. You got to have more positives. So the 10's got to be positive. The 4 has got to be negative. Okay. Now, the last one. You can look and look all day and you're not going to find a pair in the integers that work. So what's going to add and give you 6 and times and give you 10? The only things that times and give 10 in the integers are 1 and 10 and 2 and 5. There's no way with negatives and positives that you can create a positive 6. So if the answer is not in the integers, that means it could be some combination of fractions or square roots or imaginaries. And this is going to be in the imaginaries, it's going to be complex. So they've got to add and give you 6, and we could do 3 plus 3, and that will give you 6. But it's got to times and give you 10, and 3 times 3 is going to give you 9. We're close, but we're not there. So if you're going to add two complex numbers, you need, this is the real part, this is the imaginary part, you need them to cancel out. So we could do like 3 plus 1 imaginary, and we could do 3 minus 1 imaginary. So when you add them, your imaginaries are going to zero out and you're left with just reals. Okay, now that is a number. 3 plus 1 imaginary, that is a combination of a real and an imaginary. So by definition, it's complex. So 3 plus I and 3 minus I, these are their conjugates. And conjugates will always add to be real, and they will times to be real. So if you times these two together, start distributing. 3 times 3 is 9. 3 times a minus I is a minus 3i, and I times 3 is a plus 3i. And then I times a negative I is a negative I squared. And I squared is a negative 1, so it's like a negative 1, which is a positive 1. And these will zero out, and you're left with 9 plus 1, and 9 plus 1 is 10. So the numbers are 3 plus I and 3 minus I. So instead of doing the guessing and checking to come across that, because that might take forever to come across, you can model with a polynomial. So this one, what two numbers add to give you 6 times to give you 8? That was x squared plus 6x plus 8. This one is x squared, add to give you 6, times to give you minus 40. And this one is x squared plus 6x times to give you 10. And then when you try and factor it, they're pretty easy, the top two, but this one, when you try and factor it, it's impossible. So you can use the quadratic formula and solve it. If you use the quadratic formula, you identify A is 1, B is 6, C is 10. So it's x equals negative b plus or minus the square root of b squared, 36 minus 4 times 1 times 10, all over 2 times a. So you can make up your own combination, what two numbers times to give you 6, or add to give you 6 times to give you 13. You can make up any combo you want, and you can figure them out with the quadratic formula. So if I simplify this is 36 minus 40, so I've got a negative 6 plus or minus the square root of a negative 4 divided by 2, and the square root of negative 4, so it's negative 6 plus or minus 2 imaginary divided by 2, and then you just divide both those by 2, so it's negative 3 plus or minus 1 imaginary. This, though, these are the roots. And I'm not really looking for the roots. I'm looking for what was before the roots. So I'm looking, in this case, I'm looking for it was x plus 10 and it was x minus 4. And if I set that equal to 0, my roots are going to be a minus 10 and a positive 4. So those are my roots, that's what I just got. So your roots are always opposite the step before. So the two numbers are 10 and a minus 4. And I'm not really interested in the roots, I need the step before. So the step before, if that's a negative 10, this is a positive 10. So if this is a negative 3 plus I, it's going to be a positive 3 plus I. And if it's a negative 3 minus I, it's going to be positive 3 minus I. And these are those two numbers.